Mike Meyer maybe doesn't need an introduction, but he's been such a good partner for Wisconsin lakes as well as for this LoonWatch program. He's conducted many, many years of research on the consequences of degraded habitats for northern Wisconsin lakes and the possibilities of doing restoration work. So his most recent work just culminated in a lot of presentations and scientific papers talking about what we can do in Wisconsin, what works and what's successful. And it's so amazing to have people focusing on things like that, on what works. He's retired after a long career with the Department of Natural Resources, but he's still active. He's maintaining a consulting business. So if you want to ask him questions about what he's up to, find him afterward too, to get a little idea of what he might be able to help you out or your lake organization with. So without any further ado, Mike Meyer.
Thank you, Eric, and it's a pleasure being here to talk about loons. I've had the pleasure of working with, I was quickly counting on my hand, 7 LoonWatch directors since I began my work in 1990, and Terry was the first I met. And the impetus for a lot of the research came from the citizen science work of LoonWatch. But in addition to that, when I began with the DNR, my task was to investigate the impact of mercury in fish on wildlife in Wisconsin. And looking through the archives and the records and the freezers, we found out that common loons had the most mercury of any wildlife species in the state via exposure to the fish they were eating. But we needed to get our hands on loons. They were not an easy critter to work with. In fact, the attempts to capture and ban loons had been ongoing for 20, 30 years. And lo and behold, a graduate student in Michigan cracked the code. His name was Dave Evers, and we contracted him to come over to Wisconsin in 1990 and teach us how to capture loons. And it was a simple night lighting technique that Dave and his crew perfected in Michigan. You go to a lake with a family of loons present, and using spotlights and a call similar to what Erica played, you can mesmerize the family and actually just net the family with a musky net. The adults are very protective of the young, but they're blinded by the lights. So they're vulnerable to capture. And all of a sudden, we could get our hands on loons in a reliable fashion. And all of a sudden, the opportunities for doing science with loons exploded. And I have some slides to show you how that happened, and the characters that participated in the work. And Wisconsin was the epicenter of loon research over the past 25 years based on our ability to reliably capture loons. And this is Dave and his crew. They are subduing a 10-pound loon on a tarp because their primary mission was to color band every loon that they captured and their young with an individual combination of colored plastic leg bands. This allowed for us to reobserve birds year after year. And Gary, those loons on your lake might have been the same loons over 30 some years. We have records of adults now coming back to the same lake for 25 plus years. And we now have records of the young coming back to the breeding area after spending 3 to 4 years away, based on reobservation of combinations of colored leg bands. So here's an adult on a lake in Vilas County, Plum Lake. It had a red band over a green band on its left leg and a silver band, U.S. Fish and Wildlife Service, over an orange band on its right leg. You had to be really quick to get these colors, but through diligence and reobservation and going back to lakes year after year, we were able to track the return rates, survival rates, and elucidate behavior. For instance, one of my colleagues learned that the divorce rate for loons is about 7% per year, so perhaps they weren't the same couple after all. But we also know that the young of the year tend to set up house right near their natal lakes, particularly the males, within about 10 to 15 miles, simply by utilizing this color banding scheme. Every loon had a unique combination of leg bands. Based on this color palette. So my task was to look at the effects of mercury on loon reproduction. And so we were able to capture over 1,000 loons, and we went out at night using Dave's technique, captured the birds, color marked them, and collected blood samples that allowed us to assess their mercury exposure. Mercury accumulates in the blood. And so we could track how well loons reproduced based on a wide range of mercury in their blood, and we learned that mercury was indeed having an effect on loon populations in Wisconsin. It was a small effect, but it was this color banding and capture technique that allowed us to do this work. I shared an office in grad school at UW-Madison with Kevin Keno, who went on to become an avian biologist at USGS Upper Midwest Environmental Science Center in La Crosse, Wisconsin. And Kevin was always interested in loons, and when he learned that we were able to get our hands on loons, he looked at this as a great opportunity to take advantage of the skill set he developed, which is using telemetry to track migratory water birds. So Kevin joined up with us. We captured loons to assess their mercury content, and he and his veterinarian staff implanted a large number of loon adults and chicks with these satellite transmitters that allowed Kevin to track their movements over time. They were probably 2 years in length, the battery length, so we got a lot of information on their migration pathways, where they wintered, where the young went their first year, and where the young spent their first couple years after leaving Wisconsin. This is just an illustration of how that information showed us that the loons from Wisconsin and Minnesota, when they began their fall migration, all went over to Lake Michigan first, particularly in the northern half of the lake. And then they would kind of slowly migrate down to the southern part of Lake Michigan by late November, early December. And then they take about 2 or 3 hops down to the Gulf of Mexico, where they wintered primarily off the west coast of Florida, from Gulf Shores, Alabama, down to about Tampa Bay, and a scattering of them along the Atlantic coast. So once again, learning how to capture loons, all of a sudden we learned a heck of a lot about wintering habitat and migration routes for loons. We also encountered a puzzling die-off of loons 2006 to 2010 in Lake Michigan. A lot of these birds we had marked wound up dying and washing ashore at Sleeping Bear Dunes in Michigan and other places along the coastline. It was a botulism E toxicity problem. It probably occurred in the 60s too, which was a big reason why the loon population probably dipped for a while. But Kevin also elucidated the primary culprit in this die-off is the invasive species that are found in numbers in the Great Lakes now. There's a Cladophora algae. When it decomposes along the lake shores, the botulism toxin that's produced is filter-fed by the quagga and zebra mussels, which accumulate it, which are then eaten by round gobies, which is an invasive fish that came in ballast water, and then loons are spending a lot of time in the fall eating round gobies now. So that's how they're getting exposed to this toxin, and Kevin was able to elucidate that pathway. The fact that we had over 3,000 color-marked loons in Wisconsin now allowed behavioral ecologists like Walter Piper to start studying loon families and identifying the dynamics of the courtship and the coupling and what we call intrusions, when loons come upon lakes that are held by territorial loons and try to take them over. Walter was really good at teasing apart what was going on in these situations. He learned that the divorce rate for loons, for instance, was 7%, and loons that were evicted were often encountered on nearby lakes trying to retake their territories. Remember, they're all color marked, so he could track individual birds over time. He also learned that some of these people often called this loon families getting together and playing. Well, they were actually fighting to the death, it turned out, in many of the cases where males were trying to hold on their territories. About 30% of the male-male territorial battles results in the death of one of the individuals. Another behavioral ecologist team that came on board was Jay Meyer and Charlie Walcott. They brought with them their expertise in understanding avian vocalizations, and they targeted that yodel call of the adult male loon as a research focus, and they learned that the larger the loon, the louder and lower the yodel call, and the less likely that lake was going to be intruded upon by other loons that want to take over a territory. These large, low yodeling loons were often the most fit, so their territories were often skipped over by other loons trying to take over territories. And then the citizen scientists. LoonWatch, as has been mentioned, has fielded over 400 now annual lake monitors that are collecting data across the state of Wisconsin on loon presence and absence, loon reproduction. And we tapped into this pool of expertise of citizen scientists for two reasons in the DNR. Number one is this is the only census of loon populations that is currently conducted in the state. So the citizen scientists themselves, every 5 years, as Erica mentioned, tell us in the state of Wisconsin how our loon population is doing by doing a one-day survey in July. 200-some volunteers go out every 5 years on the same day, the same morning, and monitor a set of lakes from which the data is extrapolated. And so this is excellent data that shows the Wisconsin loon population is indeed expanding. And we took advantage of the citizen scientists' data as well with our Mercury study. We recruited a variety of loon citizen scientists to provide us reproduction data of loons on lakes that we were studying Mercury. And so when our budgets got cut, we were able to turn to citizen scientists and ask them to collect the reproduction data on the lakes. And we also had to certify that their lake data was accurate. So we sent our own biologist to a set of lakes that the citizen scientists were working on, and we compared what we saw with what they saw, and we found the citizen science data was 97% accurate. So it was certified and usable in our research, and it saved us a lot of money and gathered a lot of data for us. And as a reward, we would invite the citizen scientists, when they had loons present that produced chicks on their lake, to come out with us and band the loons at night. And then they got to pose with a little cameo shot with their loon chick, which they would usually promptly name. So the citizen scientists were directly involved in loon research, and I just gave you a quick overview of all the breaking research that occurred over the past 25 years. There's a variety of other researchers that worked in Wisconsin. 7 graduate projects were completed here. A couple other professors that did work here were Alec Lindsay and escapes my memory right now. So anyways, Wisconsin was the epicenter of loon research and continues to be to this day. Walter Piper, if you go to loonproject.org, has a ton of information on loon natural history. Jay Meggers has a variety of published materials on loon vocalizations, and Kevin Keno, all that migration data that he's collected in Wisconsin, Minnesota, and in New England is available online by just Googling loon migration, maps, and a lot of videos of him doing the work. So I encourage you to take a look at that. So it was an exciting time to work on loons in Wisconsin. The work continues, and thanks to LoonWatch and the loon citizen scientists for being active players in this.